Today, on how it's made. Carbon fiber masts. Making these sailing masts is a tall order. Fortune cookies. We'll bring you words of wisdom from the assembly line. IMAX projectors. Making them is quite a show. And roller chains. We'll tell you about their many strong points. In the world of sailing, lightweight ideas are the best kind. This carbon fiber mast is a good example. At half the weight of aluminum or wood, it allows the boat to move faster, and it's a pillar of strength, easily holding up a full sail. Whether you're a sailor or a passenger, it's nice to know you can count on its support. They launch production of a sailboat mast with a strip of carbon fiber. They wrap it around a long mast form, which will serve as a mold. They trim the material and peel away the paper backing. Between 20 and 100 layers will be wound around the mold, depending on the size of the mast. They apply some layers in a crisscross manner to give the mast more structural integrity and help it hold its shape. They cut away the overlap so that the edges meet perfectly. The material is a bit creased and bulky at this point, so they wrap it with plastic tape to compress it. Then they remove it. This temporary taping is done after each layer, but they leave it on after the final one and tape a breather cloth around it. Then they pull a long plastic vacuum bag over the entire thing. They seal the ends with tape. They attach the vacuum connector and hose and turn it on. It sucks air from between the carbon layers, compressing them further. Next, it all heads into an autoclave to be baked under pressure. This will squeeze more air from the layers. At the same time, the heat will activate the glue impregnated into the material, permanently fusing the layers. They make this fitting in a similar fashion. It's called a gooseneck plate, and it will connect a boom or a spinnaker pole to the mast. Back to the mast. They pull the big aluminum mold out of the mast tube. Using a disc sander, they rough up the surface so paint will stick. They drill 2 holes, and using a jigsaw with a special blade, they connect them, making one wide slot. And remember the gooseneck plate? They trim it, using the jigsaw so that it will fit snugly on the mast. Next, a worker maneuvers a plastic pipe with a string on the end. He threads the string through the mast tube, then hooks it and pulls it out of the slot made earlier. It's a messenger line, and it will be used to install the rope halyard that will raise the sail. They also use messenger strings to install electrical wiring, connecting such things as radar, horns, and lights. They're all funneled through the inside of the mast. The mast has now been painted, and a worker installs the upper end of the pulley system for the halyard. He slides in a pin that holds the halyard pulley and bolts on a guard to keep the rope from fraying. Next, they screw on a device that will let the captain know which way the wind is blowing, the wind indicator. He twist locks a signal light to the top of the mast. It will indicate the boat's direction to passing vessels. Now they attach a piece called the toggle. It's a connector piece between the gooseneck plate and the boom. This carbon fiber mast is now seaworthy, and it should make the trip a real breeze. The fortune cookie is a munchie with a message, and the message is usually as sweet as the sugary shell. But there is one surprising thing about the fortune cookie. It wasn't invented in China, but in California in the early part of the 20th century, and people in China have never really developed a taste for it. Yes, the fortune cookie is about as American as apple pie. But more than pie, it gives you a thought to chew on. To make a batch of fortune cookies, they start with a sack of sugar. They empty the whole thing into a big steel mixer. Fortune cookies are about 20% sugar. They add some food coloring, just enough to turn the cookies that distinctive gold shade. Then some melted vegetable shortening. They pour in some starch as a thickener. Pipes spray water into the mix. And then they add the pastry flour. This soft wheat flour will give the cookies their texture. They add a bit more water because too little of it would make for a crumbly batch. Then it's time to mix it all up. After a few minutes, they check the consistency. Then they pour in more melted shortening and a soy-based lecithin. Once that's blended in, the cookie mix ebbs from the bowl as a hose pumps it out from the bottom. Next, ejector nozzles squirt the batter onto hot-moving trays, making precise little patties that look like regular cookies. You could call this the Wheel of Fortune cookies. Hot molding plates revolve, each one descends and presses onto 4 fortune cookie patties, flattening and shaping them. They travel through an oven that's over 9 meters in length and bake for about a minute. They come out of the oven piping hot and are given no time to cool down because these fortune cookie patties need to stay soft so they can be easily manipulated in the next step. Steel prongs push little paper fortunes into each cookie as they fold it into that distinctive butterfly shape. There are 5,000 different fortunes in the mix at this factory. So you could say a lot of thought has gone into this process. This plant makes 4 million fortune cookies every day, enough to make a bit of a fortune. The folding molds open as the track descends. The fortune cookies, now cooled and crispy, drop to a conveyor below. It takes each fortune cookie through a wrapping mechanism which envelops it in plastic. Then a hot blade cuts and seals the package in one fell swoop. The packaged fortune cookies transfer to another conveyor, which transports them to an inspection station, where many production lines converge. A worker checks to make sure there are no breaks in the package or the cookie. He tosses out any rejects. After all, a broken fortune cookie could be bad luck. A box moves into position and hundreds of cookies fall into it, 350 cookies to be precise. They're portioned out by a scale overhead. Then a plastic ram gently presses the cookies into the box to reduce the bulk. A conveyor belt moves the box full of cookies under a metal bar, which pushes the flaps down to close it. And now the time has come to crack open the cookie in the proverbial ritual. Hey, it looks like this could be our lucky break. So, you want to be on the big screen? You won't get there without a movie projector. It was invented over a century ago, and the concept is the same today. Film revolves in front of a light which projects an image onto a screen. But the latest technological advancements make the projector a real showpiece. Its film is 10 times larger than normal, and the projector magnifies it 400 times as it moves in a sideways rolling loop rather than the traditional vertical feed. And instead of the usual sprockets, registration pins retract as the film loads and then reach out to steady it as it rolls. A vacuum sucks the film to the aperture lens. This is how they keep the gigantic image perfectly steady. To make an IMAX projector, they bolt two prisms together and mount them on a part called the lower illumination module. The prisms and a mirror will reflect the projector's light to a similar part called the upper illumination module, which will relay the light to the lens. It's a fly's eye lens, a collection of mini lenses on one glass. Each will focus to a single point, ensuring an even distribution of light. A technician screws two fly's eye lenses together and then places them in a fixture to align the two halves. He switches on a light and places an alignment guide over the lenses. There are red and green filters on this guide, and he brings them into focus. He adjusts them until the red and green lines merge. It means the two fly's eye lenses are now aligned. Next, they install the upper illumination module in the projector frame. And then they flip it. They remove the protective cap from the back. Then they attach it to the lower illumination module, which we saw assembled earlier. Here they bolt together the rotor support and motor. The rotor is this big wheel. It's the heart of the projector. It drives the film forward in that distinctive wave-like action. This piece, called a stator, will act as a guide for the film. He fits the aperture block on the front of the frame. Using a crane, they lower it onto the base. They screw in spacer bars and install the second projector assembly. These two assemblies will enable the system to run three-dimensional movies. Now it's time to position the main lens at the front of the projector. They remove the lens caps, and it's ready to roll. The film wave happens 24 times a second. We've slowed down this footage so you can see it all happen. The film of a test chart ripples in front of the aperture and then vacuums pull it down for a 24th of a second. This eliminates any shakiness in the projected image. Now we're showing it in real time. You get the picture. There's also nothing ordinary about the lamps the IMAX projector uses. They're very powerful, but they use the light very efficiently. And now, it's time to enjoy the show. Roller chains carry a lot of power in our society. We're all familiar with them as the chains that move energy to the wheels of our bikes. But roller chains also transfer energy in industrial and agricultural machinery. They really keep things moving, and without them, a lot of important equipment would be powerless. To make a roller chain, a punch press pulls steel from a giant spool. Using 500 tons of force, it cuts shapes out of the steel. These shapes are the link plates that will join all the parts of the roller chain. The plates travel on a series of conveyors. An arm positions them as they head towards the next punch press that makes 2 holes in each link plate. A worker then pours them onto a tray and spreads them evenly across it. A vibratory mechanism shuffles them into a blazing furnace. This heat treatment toughens the steel. Then they cool down slowly in a tank of oil. After that, they go for a tumble in the washer to get rid of the oily residue. Meanwhile, another machine uncoils some steel to make bushings or sleeves for the chain pins. The blade slices the material to the correct length. Then mechanical arms fold the steel around a mandrel. Here's the action in slow motion. In real time, it all happens faster than you can blink an eye. The bushings fall into a bin. And now they're ready to be heat treated. They open the furnace and stand away from the blast. A rail car takes the bushings into the flames. This may look destructive, but the bushings will come out stronger. Now it's time to make the pin that will hold everything together. This machine shoves a steel rod into a jig and a saw cuts it to size, which varies depending on the chain it'll be used for. A mechanical arm then picks up the pin and transports it to rotating heads, which machine down the ends. The pins then travel across a grinding wheel, which reduces them to a specific diameter. Next, they go through a wash cycle. A special mix of lubricant and solvents rinses away the residue from the grinding. These are the pins before and after grinding. Now it's time to put the pieces together. This is a breakdown of what happens at a blurring pace on the assembly line. The link plates and bushings go into an assembly device. A ram presses them together. They remove them and place 2 more link plates in the device. They position rollers on top of them and slide the bushings and link plate assembly into place. They press fit it all together. And now they have links for the roller chain. The next step is to fit the roller links together. They clamp them into a fixture and slide in pins. A hydraulic ram presses the pins to the base of the assembly. Then they connect the pins with another link plate and press it in place. This is repeated as they lengthen the roller chain. They can also widen it to enable it to handle more horsepower. To do this, they stack single strands of roller chain. They use longer pins to hold all the layers together. Again, a fixture holds it in place while the ram does its work. This produces heavy-duty roller chain. The one shown can handle 400 horsepower. Finally, they lower the roller chain into a vat of hot grease to lubricate the joints. And that's the chain of events that leads to the roller chain.